Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to CET JEE classes of the Algebra basic concepts. In the previous class we had studied about the number system first of all, and then the law of indices and certs, and then finally we learnt some of the important products. Okay. Now coming to the next concept, partial fractions. This is a fresh topic for you. Alright, you have studied this topic in the chapter integrals. Okay, so in integration chapter you have learned this in detail. I am sure you all remember this. Now let me just revise this quickly so that your memory is fresh. And expression of the form f of x is equal to a naught plus a1x plus a n x to the power n, where a n is not equal to 0. Okay, so a naught, a1 and all those belong to the real numbers, but n belongs to the whole numbers. Okay, so this n belongs to whole numbers. So you should have x to the power 0, x to the power 1, 2, 3, 4 integers, not decimals. X to the power 0.5, x to the power 0.1 and all that is not acceptable in a polynomial. Okay, so if you have those conditions fulfilled, then such an expression is called a polynomial in x of degree n. So understand this word degree n. All right, that's very important. Okay, so if you have let us say x square plus 2x plus 1. Okay, so what is the highest power here? 2. Therefore, what is the degree of this polynomial? Okay, if you write this as f of x, so what is the degree of the polynomial? 2. So 2 is the degree of the polynomial. So remember that. Now anything of the form f of x by g of x, where f of x and g of x are polynomials, so that must satisfy this condition. It must be a polynomial. And anything of the type f of x by g of x, where g of x is not equal to 0, that condition is also there. Okay, g of x is not equal to 0 is called a rational function. Well, so that is fulfilled here. A n is not equal to 0. Okay, so this is not equal to 0. Well, next, if degree of f of x, degree of the numerator, is less than degree of g of x, the denominator, then it is called proper. Okay, I'll give an example. If you have f of x divided by g of x like this, here you have x cube. Okay, you have anything? Okay, but degree is 3 here, degree is 2. So degree of f of x is strictly less than degree of g of x, then it is called proper fraction. But if you have, let us say this is 2 here, okay, then degree of f of x will be equal to degree of g of x. They are equal, then it is called improper fraction. Or if you have let us say 2x plus 1 in the numerator, then it is proper. If you have x cube plus 2x square, then it is improper, because degree of f of x is greater than degree of g of x. Okay, I hope you understood. It shouldn't be equal and this shouldn't be more than the denominator, then it will be proper. So when it is proper, when it is strictly less, it shouldn't be equal, shouldn't be more than the denominator. Okay, so now if you have improper fraction, then it can be expressed as a sum of a polynomial and a proper fraction. So this can be expressed as let us say q of x plus r of x by s of x or whatever. Okay, right? So where q of x is a polynomial and r of x by s of x is a proper fraction. So that can be done by long division method. I hope you remember that long division method. Well, so that brings us to the next concept. Okay, so the different formulas for partial fractions. Well, now if you have a rational function, how do you write the partial fractions of it? You have totally 5 types here. You have already learned that. I'm just trying to revise those concepts here. The first one, if you have anything like px plus q divided by x plus a into x plus b, then how do you split this as a partial fractions? So you can write this as a by x plus a, that means the first factor, and b by the second factor. Alright, so this is the way you can write a partial fractions. This is a fraction, that is also fraction. So both partial coming together makes the complete rational function. So therefore they are called partial, half. Okay, need not be exactly half, but a part of it. This is one part, that is another part. So partially we are separating them. Okay, partial fractions. Well, next, how do you write if you have anything like this? Let us say px plus q divided by you have repeated factors, that means x plus a whole square, let us say. Alright, that means you have x plus a into x plus a, both the factors are same, they are repeated. Then how do you write this? You write this as a by first x plus a, okay, first without square, then with the square. So with square we can write x plus a whole square. So remember, first without square and then with square. Don't write like x plus a and x plus a. It's not the way of writing it. This is the way of writing it. We can do the examples and understand why we have to write like this. So only the examples will tell us the real meaning of it. Now the third type, let us say you have px square plus qx plus r, and in the denominator you have 3 things: x plus a, x plus b and x plus c. So if you have 3 factors and you have a quadratic equation on the numerator, okay, you can have a linear function, linear equation also, doesn't matter, linear polynomial also doesn't matter. Okay, so only thing, the degree must be less than the denominator. Understand what is the degree of this? X cube, so degree is 3 when you multiply. Okay, so here the degree is 2, so degree of f of x is strictly less than the degree of g of x, so it is proper fraction. So if it is proper, then only we can write partial fractions, otherwise we cannot. We have to make it proper first. Okay, anyway, now how do you split it? We split it like first a divided by x plus a, then b divided by x plus b, and then you have x plus c as well. So take the constant c for x plus c. So that's the way we write. So this is comparable, correct? Now you may have 2 things repeated but 1 separate thing, then how do you write? Okay, that is the 4th type. So if you have px square plus qx plus r divided by, you have x plus a repeated, and then you have x plus b. Okay, so you will have 3 things, but how do you write them? So first we'll write for x plus a whole square. So if you have whole square, you write without square and with square. Now also do the same. So you write first without square, that is x plus a, and then you write with the square, and then you have one more factor, right, x plus b. So third constant you take and you write x plus b, that is independent. Okay, so this is repeated. So for the repeated thing, how do we write? Without square and with square, and then third independent, write it c by x plus b. These are the four types which are similar. Okay, so these two are similar and these two are similar. Alright, now the fifth type, that is different. So what is the fifth type of the rational function? The fifth type of the rational function is this. You have px square plus qx plus r divided by, you have a factor x plus a, let us say, and you have a quadratic equation. You have x square plus let me write bx plus c. Okay, so what is this? You have a quadratic equation which cannot be factorized further. Okay, so you have a quadratic equation which cannot be written as a product of two factors. Then how do you write the partial fractions? Understand? Okay, so first for x plus a, so write a by x plus a, that's easy. Right, now you have a quadratic equation, therefore you take a linear polynomial, that is you take bx plus c. You need to have two constants because the degree is 2. Okay, here the degree is 1, one constant is enough. Okay, and you have to write the quadratic equation here. Okay, so this is the way we can write the partial fractions of a quadratic equation which cannot be factorized. So if you are not able to factorize it, take two constants anyway, but with a combination of x. Okay, so write it as a bx plus c, a linear equation. Let us continue with the partial fractions. See, as we have learnt 5 formulas, let us divide the problems into 4 types here. Okay, so there are totally 4 types of the problems in partial fractions. You can expect totally 4 types in this. Now, the first type is non-repeated linear factors. Non-repeated linear factors in the denominator. So in the denominator you have non-repeated linear factors. You have the first linear factor, second and the third. So 3 factors which are not quadratic, linear factors. Okay, and they are not repeated. Then it's very easy to simplify. You have 3 things, therefore you take 3 constants. So write it as a by x plus b by the second factor, that is x plus 1, and then c by x minus 3. Well, now what is the next step? You must take the LCM. So LCM is product of all the 3. So write it like this. Now for a, what is missing here? These 2 things. So multiply them here, correct? So x plus 1, x minus 3, and then b. So what is missing here? X and x minus 3. So multiply x and x minus 3, and for c, x and x plus 1. Well, so now what is the next thing? The denominator can be cancelled, and what remains is 3x plus 4, that is equal to a into x plus 1 x minus 3, yes, and plus b into x minus 3, and then c x plus 1. Well, so I hope you understood that, cancelling the denominator. Well, so the denominators are cancelled on the both sides, so only the numerators remain. Well, after the cancelling of the denominators, now what is left is finding the values of a, b and c. Well, so there is a shortcut method. See, there are 2 methods now. The first method is comparing the coefficients. You can compare the coefficients of x, x square and the constant. Alright, so 3 things you can compare and find the values of a, b and c, which is a lengthy process, but there is a shortcut method. The shortcut method is you just make two things 0, find the third, and so on. Okay, so I'll tell you how. I hope you know that method already. Okay, so put x is equal to, I want to make b and c 0. So how can I make b and c 0? Put x is equal to 0. Okay, so put x is equal to 0, you will get the value of a directly. So when I put x is equal to 0, I have to put here also. So 4 is equal to, this is 0 plus 1 because x is 0. So if x is 0, this is 0 plus 1, and this is 0 minus 3. So that is minus 3, and these two things will be zeros because 0 is multiplied. Well, the next thing, I need to find the value of a. So this is minus 3. Minus 3 will be divided here. Therefore, the value of a is minus 4 by 3. That minus 3 will be divided. So minus 4 by 3. Now I need to find the value of b and c. Now what I do, I will make a and c 0. So how to make a and c 0? See, put minus 1 here. Minus 1 plus 1 will be 0, and put minus 1 here. Minus 1 plus 1 will be 0. So c will be 0. A part also will be 0. We will get the value of b there. That's easy, right? So let me write it there. I have some space here. So next, put x is equal to minus 1. So when I put minus 1, this will be minus 3 and plus 4. That is equal to, this will be 0 as I explained already, and b into x is minus 1. So minus 1, and this is minus 1 minus 3. So that is minus 4, and the last part will be 0 there. Okay, so this is 1, 4 minus 3, and then this is 4 b. So b is equal to 1 by 4, right? So that is 1 by 4. Well, now finally I need the value of c, therefore I should make these two zeros. So put 3 here. So 3 minus 3 will be 0. Put 3 here. 3 minus 3 will be 0. So now you put x is equal to 3. So when you put x is equal to 3, you have to substitute here also. So 3 into 3, that is 9 plus 4. So 9 plus 4, and then a will be 0, b will be 0. So c into x is 3, and then 3 plus 1 is 4, right? So 9 plus 4 is 13. And then this is 12c. 3 4s are 12. Well, so c is 13 by 12. That will be divided. Well, now you have got the values of a, b and c. Finally you substitute here. That's your partial fractions. Okay, so now finally I need to substitute the values of a, b and c. Okay, so let me substitute the values of a, b, c here, and that's it. Okay, so this is minus 4 by 3, and then b is 1 by 4, and then c is 13 by 12. Okay, so let me write it decently. So how can I write? So we can write it as minus 4 by 3x. This is x by 1. When it goes up, 1 by x should be multiplied. So x will come here, right? Similarly here, 1 by 4 into x plus 1. That 4 will come in the denominator. Otherwise, you can think like this. This is 1 by. So when it goes up, 1 by x plus 1 here. Okay, fine. Now here, this is like 13 in the numerator. So this is divided by 1. So 1 by x minus 3 here. So 12 into x minus 3 there. So that is the factors that we were expecting. Well, let's move on to the second type. Well, the second type is repeated factors, okay, repeated linear factors, not quadratic, linear factors. See, this is repeated, x plus 2 into x plus 2 it is, alright, in the denominator. Well, now if you have repeated, you know which formula to use. So the first is a independently, so that is x minus 1 plus b, so without square first, and then with the square, with the constant c. So this is the way we must write the partial fractions. Now what is left? To find the value of ABC. So what we must do? Take the LCM. Now when you take the LCM is this, okay, so that we can cancel it later. So that's the way you can remember. So you have to take the same denominator. All right, don't take it once again, don't write whole cube, okay, so twice is enough. I'll tell you why. Now what is missing here? X plus 2 whole square, so multiply. So this will be a into x plus 2 whole square, b into, this is important. Now you have x plus 2 once, but you need twice in the denominator, so you must multiply x plus 2, and x minus 1 is also missing, so x minus 1 also you should multiply, and x plus 2 also, because it is there only once, but we need it twice. Fine. Now x plus 2 whole square is already there, so what is missing is x minus 1, so multiply c into x minus 1. Now there are two shortcut methods. The first one, you can make b and c 0 half, put x is equal to 1, that becomes 0. Next you can make this a and b 0, you can find the value of c, but to find the value of b we need to compare the coefficients of x square, that is one thing, or we can put anything else and put the values of a and c. Okay, so don't be worried, now we will solve it and you will understand. Well, now cancel the denominators, so numerators remain. First is 5x square plus 3x plus 2 is equal to a into x plus 2 whole square plus b into x minus 1 x plus 2 and then c into x minus 1. Well, hope you understood that. Fine. Now put x is equal to what? 1, so that those two things become 0. So when you put 1 here, this will be 5 into 1 square plus 3 and plus 2, and here a you have to put 1, right? So when you put 1 plus 2, 3 square, and these two things will be zeros, mention it. Fine. Now this is 8 plus 2, 10, that will be 9. So what is the value of a? So the value of a is 10 by 9, correct? So 9 will be divided here, 10 by 9. Next we have to put x is equal to minus 2. See, when you put x is equal to minus 2, this will be 0 and this also will be 0, we will get c. Okay, so put minus 2. So when you put minus 2, calculate carefully. This is 5 into minus 2 square, 5 into 4 I will write as it is, plus 3 into minus 2 plus 2, that is equal to, now this will be 0 and even this will be 0, correct? So only c will remain. Okay, so we can write it here, and this is minus 2. So minus 2 minus 1 is minus 3. Well, so this is 5 4s are 20, and then minus 6 plus 2, that is equal to minus 3c. So this is 20, minus 6 is 14, 14 plus 2 is 16. So c is minus 16 by 3. So minus 3 will be divided there. Fine. Last, you have to find the values of a, b, c. Now we have got a and c, so find the value of b. So to find the value of b, I will write here Okay, to find the value of C, I think I can write on the top. So let me write it on the top. Okay, so to find the value of B, we will put x is equal to 0. You can put anything practically. Okay, 0 is better because the left hand side will be only 2. That is equal to the value of A we know 10 by 9. Substitute it, and this part is 0, so 2 square into 4 plus B into, now this is 0, so minus 1, this is 0, so into 2 plus the value of C we know, that is minus 16 by 3, right, and then this is 0, so minus 1. Okay, so eventually that will be plus. Well, so this is the thing that we have to simplify, right? Okay, now what you will do, you will multiply. So 2 40 by 9, and this is minus 2b, minus 1 into 2, minus 2, and this is plus 16 by 3. What is the LCM? LCM is 9. Before that, take 2b here. So 2b is equal to 40 by 9, and that will be plus 16 by 3, and this will be minus 2 here. So LCM is 9. Okay, so when you take the LCM 9, what's happening here? This will be 40, multiply 3 here, correct? So that is 48, minus multiply 9 here, that will be 18. So this is 48 minus 18, which is 30, 30 plus 40 is 70, 70 by 9, that's not the answer, that is 2b. So finally B is, see this 2, and this is 35, so that is 35 by 9. Well, once you get all the values of A, B and C, what you have to do is substitute in the original equation. Therefore, your original equation becomes 5x square 3x plus 2 divided by x minus 1 into x plus 2 whole square is equal to, first A is what, 10 by 9 divided by x minus 1 plus, now next is B, and B is what, 35 by 9 divided by x plus 2 and plus minus 16 by 3 the value of C, and with the square x plus 2 whole square. Well, so just let us write one more step, write it in proper order. So when you write it in proper order, this is 10 by 9 into x minus 1 plus 35 and 9 into x plus 2 minus 16 and 3 into x plus 2 whole square. So that is the partial fraction of it. Well, the next type, the third type, you have a non-factorizable, irreducible quadratic factor in the denominator. You cannot factorize it further. Why you cannot factorize it? See, when you add, you must get 2. When you multiply also, you must get 2. So what are the factors? How do you shift? How do you split this? You cannot split it, right? See, why you cannot split? Because x is equal to, what is b square minus 4ac? Is it a perfect square? If it is perfect square, then you can split it. See, b square is 4 minus 4 into 1 into 2. So that is 4 minus 8. So which is minus 4. So you cannot factorize it. So you are getting negative here. So negative means it will be complex roots. Okay, so roots will be complex for x value, and you cannot factorize it. Okay, so if you are not able to factorize, see, when you multiply you must get 2, 1 into 2. Okay, so that is 2x square must be split, and when you add these things you must get 2x. So can you do it? You cannot. Okay, so what we will do, we will use the formula, the fifth formula, where the quadratic equation cannot be factorized, non-factorizable, irreducible quadratic equation. So how you should write? You should write a linear polynomial in the numerator with a and b. You don't have to take c. Okay, there is only one thing now. There is no other factors, so a by that not required. Directly go for ax plus b divided by x square plus 2x plus 2. Right? Yes. Now cancel the denominators. So what remains is x minus 3 ax plus b. So get the values of a and b. So what you will do in the shortcut method, put x is equal to 0. Okay, so when you put x is equal to 0, so this is minus 3, that is equal to b, and that's the value of b. Well, next now you got the value of b, so substitute. So x minus 3 ax, and this is minus 3. We need the value of a, so we have x term there. You can compare the coefficients of x. So a is equal to 1, correct? A is equal to 1, so that is one way. Or if you want substitution with some value, you can take x is equal to 1 or anything. Okay, so put x is equal to 1. See, when you put x is equal to 1, what will happen? This is 1 minus 3, that is equal to a into 1, and b is minus 3. Okay, so this is minus 2 and this is a minus 3. So a is equal to minus 3 becomes plus 3 here. So that is 3 minus 2, which is 1. So a is equal to 1 in whatever way you solve it. So finally, how do you write this x minus 3 divided by x square plus 2x plus 2? How do you split it? See, first a and x. So what is a? 1. So 1 into x plus b. So b is minus 3. So write it minus 3 divided by you are getting x square plus 2x plus 2. That's it. Alright. So these are comparable with each other. Alright. So that's the way we can split this in the third type. Now let us move on to the fourth type. Fourth type is an improper. You have, okay, so you have an improper fraction. We'll take the example. This is the fourth type. Okay, so that is the fourth type. Now let us take an example of x square minus x plus 1, x square minus x plus 1 divided by, you have x square minus 3x plus 2. Alright. Now why are we saying this is improper? Because look at the degree of the numerator. Degree of f of x is equal to the degree of g of x. If the degrees are equal, then it is improper fractions. It must be converted into proper sum of polynomial and a proper fraction. So how we can do that? By long division method. So understand this. We are going in for long division method. So x square minus x plus 1 must be divided by x square minus 3x plus 2. Well, you have x square, therefore 1, and this will be 1 should be multiplied for all the 3. So 1 into minus 3x, 1 into 2, that is plus 2 here. So subtract, these will change the signs, so that will cancel, and minus and plus plus 3 minus 1, so 2, and this is minus, so minus 2 plus 1 minus 1. Well, now how can you write this as improper fraction? Alright, so first 1 plus, you have the remainder here. Remainder is 2x minus 1 divided by you have the denominator, and that is x square plus minus 3x plus 2. Well, so that is equal to, that's equal to 1 plus, what do you have next? You have a divided by, see, this can be written as x minus 1 into x minus 2, correct? Okay, so that will be minus x minus 2x minus 3x minus 1 into minus 2 is plus 2. So these are the factors, you can factorize it. Okay, so when you add you should get minus 3, when you multiply you should get 2. So minus 1 and minus 2, that can be done, fine. Okay, now how do you split it? So this can be split like a by x minus 1 plus b by x minus 2. Okay, in other words, we can take only this part, get the values of a and b and substitute back, that is also fine. So I will do that method if this is confusing. Okay, now what I'll do is I will take this expression as the equation number 1. Now let me take only 2x minus 1 divided by x minus 1 into x minus 2. So this is like a divided by x minus 1 plus b divided by x minus 2, is it not? Yes. Okay, so this is equal to take the LCM, so that should be multiplied here, and x minus 1 should be multiplied here. Denominators are x minus 1 and x minus 2, which can be cancelled on both sides, so I am not going to write that step here. Okay, well, now what remains is only 2x minus 1. You can compare the coefficients of a and b, I mean x and constant. Okay, otherwise you can put x is equal to 2, x is equal to 1. So let me put x is equal to 1 first, shortcut method. Okay, so put x is equal to 1. So when I put 1 here, this will be 2 minus 1, and when I put 1, this will be 1 minus 2, which is minus 1, and that part will be 0 because I am putting 1. 1 minus 1 is 0. Okay, so this is minus 1 into a, which is minus a, and here 2 minus 1 is 1. So what is the value of a? The value of a is minus 1. Next, I have to find the value of b, so I'll put x is equal to 2, obviously. So put x is equal to 2. So when I put x is equal to 2, this will be 2 into 2, 4 minus 1, and when I put 2, this will be 0. So b into 2 minus 1. Okay, so the value of b is 4 minus 1, which is 3. So a is equal to minus 1, b is equal to 3. Now what I have to write is this finally. So how I am going to write that? Okay, so understand how we can write this. In the final step, you have to substitute the values of a and b finally, and you have 1 here, so let it be. But in this place I should write this. So a is minus 1 divided by the first factor, b is 3 divided by x minus 2. So finally it can be written as 1 minus 1 by x minus 1, 3 by x minus 2. These are the factors of this improper factor. Okay, so improper fractions can be made into proper first by long division method. Okay, and partial fractions are written, find the values of a and b finally. That's it. About partial fractions, you have got totally 4 methods, okay, 4 type of problems, totally 5 formulas. Please remember this will be helpful for you to solve the specific problems of any chapter well. So thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.